Good morning, or afternoon, or evening, everyone. I hope everyone had a fantastic weekend. If not, then better luck next weekend, right? No, I hope everybody had a really good weekend. Um, we're going to be getting into a little bit more on derivatives here. Now, you know that the derivative was the equation of the tangent line, right? Or it was the slope of the tangent line, rather, excuse me. It was the slope of the tangent line. So today we're going to be talking about writing equations of tangent lines. So there's a couple things you'll need to remember. I'm just going to write these down up here. First off, you'll need to remember your difference quotient. So if you'll remember your different, ooh, wow, I can't see that at all. Difference quotient. And your difference quotient, let me get in on this. If you'll remember, the difference quotient is the limit. Well, here, let me write it this way. F prime of C is equal to the limit as x goes to C of f of x minus f of C over x minus C, like your slope, right? A couple things to remember about the difference quotient here. That is f prime, f derivative. A couple things to remember about this. It gives you the slope of a tangent line at C. And you're always going to use this when you know C. Alright, so write a little note here. Use it when you know C. Use it when you know C. I zoomed in too much, didn't I? Use it when you know C. For example, number one, straight out of the box here. There we go. Find the equation of the tangent line at a graph of y equals 1 minus x squared at x equals 3. So first thing, you have a couple of points here. One of those points is 3, comma, f of 3, which is going to give you, if you plug a 3 in right here, f of 3, 3 squared is 9. 1 minus 9 is 8, negative 8. So the point here is going to be 3, comma, negative 8. See if I can bring that brightness down just a hair. 3, comma, negative 8. The other point you've got is x, f of x, right? Which is really nothing shocking. You have x and f of x, which is your y value. That's going to be x and 1 minus x squared. All I'm doing is plugging in the equation for f of x here. So it's asking us to find the equation of the tangent line. Well, I have a point. Now the only thing that's missing from that is a slope. If you have a point, find your slope, and that'll tell you what your line is. Okay, so here's your point. So the next thing I'm going to come up with is the slope. And how do you come up with the slope? F prime of 3 is equal to the limit as x goes to 3 of f of x, which is 1 minus x squared, minus f of c, which is negative 8, over x minus c. Excuse me. Now, there's a couple of things going on here. 1 minus x squared minus negative 8. If you take your minus negative 8, combine them, you'll get a plus 8. So you've got a, let me simplify this here, we've got the limit as x goes to 3. Now this would be a negative x, and you've got a positive 1 and a positive 8, so, or excuse me, negative x squared, positive 1, positive 8, so plus 9, where x minus 3. Now the top here is really close to being a difference of two squares. All I have to do to get it there, limit as x approaches 3, is to take out a negative out of the top, and I've got x squared minus 9. Now you may be asking, Mr. Ballard, how did you know to do that? Well, I look in the bottom here, I've got an x minus 3, and I want to try and simplify this somehow, because if I plug a 3 in right now, it's just going to go to 0 on the bottom. I want to try and simplify this somehow. So let's bring it down here. That's going to be the limit as x goes to 3 of negative x plus 3, x minus 3, if you factor the top, over x minus 3. Those will go away. So we've got the limit as x goes to 3 of negative, you know what, let's go ahead and distribute that negative. Why not? Negative x minus 3. Plug in a 3 in there and you have negative 3 minus 3, negative 6. Remember that this is your slope. Bam! Negative 6 is your slope. So I've got some space over here on the right. I've got a point of 3 comma negative 8. I've got a slope of negative 6. So I'm just going to plug into my equation y minus negative 8, which is plus 8, equals m, negative 6, times x minus x1, which is x minus 3. Alright? Really not much to it. You find your point that you're given here, figure out what your point's going to be, find the limit as you're going to your c value, that's your slope, plug it into point slope form. Y minus y1 equals m times x minus x1. Alright? Let's go to the bottom, or example 2. Next, find the equation of the tangent line to the graph of y equals 2x at the point 1 comma 2. Okay, so first off here, I'm going to write down the point that they gave me. Remember, it's c comma f of c, which is 1 comma 2 in this case. So here they give me a point. Notice up here, they just gave me a value for x. Down here, they actually give me a point. So I've got a point here of 1 comma 2. So what I'm trying to do is use this x value of 1 as my value for c. So in that case, find your slope. You're still going to that point, right? That point is your x value. 1 comma 2 is your actual point. 1 is your x value, or your c value in this case. So let's go to that value. So we've got f prime of 1 is the limit as x goes to 1. Your function is 2 over x, so it's 2 over x minus f of c over x minus c. Okay? Okay, now there's a couple of things that that we can do to this. Remember that we're trying to simplify our function here, right? We're trying to get this thing to be to the point where we can cancel something out of the top and bottom. So I'm going to do something that's a little bit different here. I need this 2 to either go to a 1, or I need something to happen up here to where this is a positive x and a negative 1, right? I need a positive x and a negative 1. So think about this here. What would it take in order to get that? Well, first, if you look at this, you're taking out from here one of these things, like this x right here, to get this out of the denominator, right? To get this out of the denominator, you would have to pull that out. To get the 2 away, we're having to pull out a 2. So watch what happens when I do this. Let's say that we take the limit here as x goes to 1, and let's actually pull out 2 over x out of everything. So like, let's pull out 2 over x here. Let's pull out 2 over x here. Now what's that going to look like? Now remember, it has to be 2x times this gives me, or 2 over x times this gives me 2 over x. Well, that's going to be 1. That's pretty easy to see. But then 2 over x times this has to give me 2. 2 over x times this would have to give me 2. So that's going to be minus x. And if you look backwards here, it's 2 over x times x. Your x's would cancel, and you'd be left with negative 2 over x minus 1. So what I've done here is I've basically just taken this fraction out of it and forced this thing to become 1 minus x. And then you can take the negative out of that, and the top and bottom will cancel, right? So let me show you that step here. All this is just being clever, right? That's all it is. We're just forcing this thing to become something we want. Now we could have done that one step at a time and pulled out a divided by x, then pulled out a multiplied by 2, factored out a 2. We could have done that all at once, but what's the point? When you can do it in one step, why do it in many? So you've got the limit as x goes to 2. You'll have a negative 2 over x. When the negative comes out of here, to make these the same, they'll cancel out, right? So you bring the negative out, these will cancel. You got negative 2 over x. Now plug in your 1, negative 2 over 1, and it's negative 2. There's your slope. All right, so you've got a point. Let me go over here. You've got a point of 1, 2. You've got a slope of negative 2, so it's going to be y minus 2 equals negative 2, x minus 1. The only part that was more difficult about this one was that pulling out a fraction bit. Just keep in mind that you're trying to pull out, you're trying to divide out what it would take to give you your denominator, or to give you something that'll at least cancel something in the denominator. All right. Okay, now let's talk about how to interpret this stuff from a graph, because this is where we're going to be doing a lot of work, is looking at graphs. So a couple of things that's happening here. It says match the function, here's your function, with the correct derivative, and they've given you 2 derivatives here that's happening. 2 derivatives. The first one, on the function here, you see that we've got a decreasing value and an increasing value. Well, why am I looking at decreasing and increasing? Because that's the slope, right? Think about it. Your slope down here is all negative. Your slope here is all positive. Let's write that down, and here's how we're going to do it. Looks kind of like a sign analysis. F of x, you got your little line here. Where it changes is negative 1, and I'm looking at the slope to the left and the slope to the right of that. Well, the slope to the left of that is all decreasing. The slope to the left of that is all negative, decreasing. The slope to the right of negative 1 is all increasing. So if we think about this, for the derivative then, f prime of x, at negative 1, that's going to change from being a negative value to being a positive value. And there's only one of these that happens on, and it's this guy right here. So this guy is the derivative of this guy, because you're looking at slope, right? You are looking at slope.